Okay, we're going to pick up where we left off, and now we are getting ready to call fminbnd to find the value that minimizes our function. So let's go ahead and run this section again so that we can remind ourselves what that plot looks like. Okay, so there it is, and we said that the value that minimizes a function is going to be something around 0.5, and the minimum value of the function looks something like -2. Okay, so try to keep that in mind. And now let's think about calling fminbnd. Okay, so fminbnd, that is not right at all, fminbnd, like that. We need to pass it our function handle, so a non-fun handle, and then the left end of our interval and the right end of our interval. So we need to decide what that might be. Okay, so anything over here and anything over here should be okay, so maybe let's do -1 and 2. And we are going to assign the output to a variable, and let's call that variable, I guess I'll do this, local minimizer, like that in camel case. Alright, so let's run this section and see what we get for the local minimizer. Alright, so in fact, since this is a simple function, the function is minimum at 0.5, like we read off the graph. So that seems good. Now our instructions here say that we should compute the function minimum. Okay, so the minimum happens at 0.5, but then what does the function evaluate to if y is 0.5? Alright, so we can simply create a variable called funmin and use our function handle to call the function, so a non-fun handle, and pass in our local minimizer variable. Alright, and now if I run this section, again the local minimizer is 0.5 and the function minimum is -2.25. Alright, so our guess was -2, but yeah, you can see that it is a little bit below -2 there on that plot. Okay, so that all seems great. And now for fun, we could add that minimum to the plot, that minimum data point. Alright, so we would need to do a hold on, and then we could say plot, and on the horizontal axis is going to be the local minimizer, and on the vertical axis will be funmin, and then let's make that a red star. Alright, so there it is. We've added a nice red star to mark the minimum of our plot. Okay, and then there's just one more thing I want to point out, that is the overloading of fminbnd. Alright, and so the overloading here that I'm going to show you is that you can request a second output that actually is the function minimum. Okay, so it's the function evaluated at the local minimizer. So up here we use the function handle to call the function and get the function minimum, but we actually could have just done it all at once by asking for a second output. Okay, so let's use our other variable names instead of that syntax stuff that we got going on there. So okay, the first output will be local minimizer, the second output will be funmin, and then we will call fminbnd, pass it our function handle, a non-fun handle, and then give it our range again, so -1 and 2 seem to work great. Okay, so let's run that section. Alright, and so now we get it twice, right, because we called fminbnd with just one output, used the function handle to get the function minimum, and then did it again where we asked for 2 outputs from fminbnd. Okay, so you can kind of do it either way. I think generally it's easier to just call fminbnd and assign 2 outputs. Alright, one other thing that we do need to look at is what happens if you don't choose good values for minval and maxval. Okay, so let's copy this line of code, and we better put a comment here that says, what about different min, val, max, val choices? Okay, all right, so paste that, and then let's do 2 to 4. All right, so left-hand side of our interval is 2, right-hand side is 4. Run section, and now it tells us that the local minimizer is 2, and that the function minimum is something small. Okay, that might throw us off, right? Because that's a small value, so maybe that is the minimum value. But if we look at the plot, clearly the function is not minimum at 2 with a value around 0. Okay, it's just that in the interval 2 to 4, that's not where the function has its actual minimum. So it didn't give us an error, it actually gave us the minimum value in that interval, right? So you have to be careful to make sure that you're getting what you want. Let's try something on the other side. So let's do -3 to -1. So that's on the other side of the what we would call the true minimum. Okay, run the section, and now it says the local minimizer is -1. Again, I chose a value that is around 0. Okay, so the lesson here is just that it's really important that your min val and max val are actually on either side of the minimum that you're looking for.